Welcome guys and girls to this lecture. In this lecture, we are going to understand what is Kubernetes. Alright, let's get started. Let's start with your application. Because at the end of the day, the reason Kubernetes exists is to run your precious application. Okay, so you packaged your code, configuration, dependencies, runtime engine, and you created Docker image or container image. And when you run this image, it creates this beautiful container. So where does this container run in Kubernetes? So Kubernetes node hosts your containers. You can think node as a physical or a virtual server. For example, Amazon EC2 can work as a node when you run Kubernetes in AWS. Typically, you have one or more nodes running container for one or more applications. So your container runs on these worker nodes. However, somebody or something needs to manage this process, such as which container should go to which node, how many copies of the container should run, does this cluster need more nodes, etc. And that is the job of Kubernetes master, also known as control plane. So control plane has a lot in its plate. So control plane has multiple components who does these functionalities. Let's take a look. The first component is ETCD. As container gets loaded into nodes, you need to have a database which saves which container is going to which nodes, what time they are getting loaded, etc. ETCD is a consistent and highly available key value store that saves all this critical cluster information. Next is kubescheduler. Kubescheduler is a control plane component that schedules your container into proper nodes. It takes multiple factors in the scheduling decisions, such as resource requirements of the container, policy constraints, data locality, inter-workload interference, etc. Next one is kube controller manager. This component ensures proper state of cluster components. Pretty sure I confused you guys and girls there. You guys and girls are probably going, what the heck is this state thing? Alright, let's take a look because this will come up in your conversations or your interviews. Kubernetes cluster state is nothing but a specific configuration. Let's say your Kubernetes cluster is supposed to run with 3 nodes. So we could say the desired state is 3 nodes. But let's say for some reason, 1 node goes down. So the current state becomes 2 nodes. So the desired state and current state is no longer equal. So what's going to happen? Kube controller manager will jump into action and it is going to observe that the desired state is not equal to current state and it is going to bring up one more node to make the current state equals to desired state. But who specifies state? Who tells Kubernetes master that I need this many nodes, I need this many copies of my container running? Well, you do. You tell Kubernetes master what state you want using manifest file. Let's say, for example, in the manifest file, you can say, hey, run 6 copies of my container image. You're going to post that to the Kubernetes master, and the kube control manager is going to observe that, all right, desired state, 6 containers, current state, 0 containers. So it is going to work with kubescheduler and schedule 6 container on the nodes and make desired state equal to current state. All right, so now we know that you using manifest file can specify a state. But how do you interact with Kubernetes master? The kubescheduler, the kube controller manager, they're not exposed outside of the cluster. So you communicate with kube API server. So this API server is a component of the Kubernetes control plane that exposes the Kubernetes API. You can think of it as front end of the Kubernetes control plane. So anytime you need to specify a state or you need to change some existing state, you always interact with this kube API server. And then the other components behind the scenes jump into action and make the desired state and current state equal. Okay, so at this point, we know about the 4 components: ETCD, scheduler, controller manager, and API server. So these 4 components are running in the control plane or Kubernetes master. Now let's take a look at the node. So to run your container, the node needs to have container runtime engine. Container runtime is the software that is responsible for running containers. Kubernetes supports several container runtimes such as Containerd, CRIO, Fracty, and of course the most popular, Docker. So until this point, we learned about the 4 control plane components that help running your container into the nodes. But something needs to run in the node as well, besides the containers. Because the master needs to communicate with the node. The master needs to tell the node, hey, run a container in this node. And as the master monitors the node, something needs to send back to the master if everything is going okay or not. So that's what Kubelet does. A kubelet is an agent that runs on each node in the cluster. It makes sure that containers are running okay. If something goes wrong, it reports back to the master. And at the same time, if the master wants to schedule a container in the nodes, it communicates that via the kubelet. All right, so master communicates with the node using kubelet. But what about node-to-node communication? Let's say you are running your database in this node and your application server in this node. How would the database server and the application server communicate with each other? That is done using kubeproxy. So kubeproxy is a network proxy that runs on each node in your cluster. It maintains network rules on nodes. These network rules allow network communication to your container from inside or outside of your cluster. So to sum it all up, Kubernetes has 2 main components: master or control plane and worker nodes or data plane. The 4 control plane components are ETCD, Kube Controller Manager, Kube Scheduler, and Kube API Server. And the node components are Kubelet, Container Runtime, and kubeproxy. Also, we are going to look at a lot of these components in detail in subsequent lecture. This is just a 30,000 feet overview of Kubernetes. So before I end this lecture, I just wanted to go over one lingo that I found confusing when I started my Kubernetes journey. So a lot of time you will hear K8s instead of Kubernetes. The reason is there are 8 letters between K and S in Kubernetes. That's why sometimes people lovingly call it K8s. Alright guys and girls, that is the video. If you are looking into getting into Kubernetes with EKS, Fargate, and DevOps, check out my highest rated course in this area in Udemy. So if you are someone who is trying to get into Kubernetes but find that the concepts are complex, I highly recommend checking out this course. Also, check out my courses in Udemy if interested. There's a big Black Friday sale going on. Check out my serverless course where we go deep into different serverless components along with all the newest features. And I keep all my courses up to date. Also, I have another course on CloudFormation, CDK with DevOps, and interview guide. I'll put the links to these courses in the description. So if you're interested, please check them out. It helps me support this channel and my other teaching activities. All right, that's all for today. Have a great day. Keep rocking cloud. I'll see you guys and girls in the next video. Bye.